So this question is coming from Feb March 16, paper 3 variant 2, and this question is the sixth question of that paper. We are given the equation of the curve, which is an implicit equation as you can see, for which y lies in between minus pi by 2 to pi by 3. The first part of the question is asking us to find the derivative with respect to x, and we have to get that in terms of x and y both. So in this case, whenever you are having an implicit equation and you are supposed to take derivative with respect to x-axis, it means that wherever there is an x term, it will be differentiated normally like what you do. But whenever there is a y term, you are going to take its derivative normally and then you multiply that with dy dx as well. So let me show that to you by doing the first part. And if you are comfortable understanding this question, I am sure any kind of implicit differentiation, you will just be comfortable following the same idea. So I'll take derivative on both the sides with respect to x-axis. So I'm having sine y dot ln x on the left hand side is equal to, I'll take derivative with respect to x-axis on the right hand side also, which is x minus 2 sine y. Just make sure you have copied the question properly. You don't want to make silly mistake over here. So sine y ln x, x minus 2 sine y. Now if I take a derivative over here, you can see that there are two terms involved over here in the format of u into v. So if you try to take the derivative, we use product rule in this case, where it's going to become the derivative of the first term, keep the second term as it is, plus derivative of the second term, keep the first term as it is. So I'm going to implement the product rule over here, keeping in mind that whenever I differentiate over here the y term, I also need to multiply with dy dx along with that. So yeah, let me show that to you how it's going to look like for the left hand side. And then I'm going to repeat the same process on the right hand side. On the right hand side, I don't think so we have any kind of a product rule. It's just a normal differentiation. So yeah, let's get started. Sin y derivative will become cos y, but then cos y was with respect to y term, so I also need to multiply this with dy dx. And then I need to keep ln x as it is. So this is the derivative of the sin y, which is multiplied then with the v as it is. And then I'm going to go ahead and say that this is plus derivative of the second term multiplied with the first term as it is. So first term is sin y and derivative of ln x is 1 over x. So I am done differentiating on the left hand side with respect to x-axis. Let me do it on the right hand side. The derivative of x is 1. The derivative of the minus 2 sin y will become minus 2 cos y. But then again we have taken derivative of y term. But we are doing with respect to x-axis, so we need to multiply it with dy dx. Now because the question is asking us to find dy dx, it means we have to make it as a subject and then get answer in terms of x and y. So let's see what do we get over here. I'll shift all the dy dx term on the left hand side and keep the other things on the right hand side. And then take dy dx in the common. So I'll take dy dx over here as the common. So for the first term, I can see cos pi ln x is remaining. So I'll write it over here. And then if I shift this to the left hand side, it will become plus 2 cos y. And then dy dx was also common, so I'll just close the bracket and say that this is same as writing 1 minus sin y over x. Now if I want, I can just have a common denominator by multiplying this term and divide this term with x. And I'll do this in the second step while dividing this thing on the right hand side. So finally I'll get my dy dx over here looking in the form as x minus sin y whole divided by x is now a common factor, so I'll just take x as it is over here and multiply cos y ln x plus 2 cos y in the denominator. If you want, you can also take cos y as a common factor in the bottom. So I'll just write x cos y and then ln x plus 2. So this is the final dy dx that I have got in terms of x and y both involved in the equation. So that's how I'm going to do the first part. So yeah, if you are aware about this thing, that if you are taking derivative with respect to x-axis, and if you are taking the derivative of y term, you always need to multiply it with dy dx as you can see over here. Apart from that, it's just a normal differentiation that you have learned and making the dy dx the subject of formula. Moving on to the second part. The second part of the question is asking us to find the exact x coordinate where the curve, there is a point on the curve at which the tangent is parallel to the x-axis. So if I'm having, let's say, a curve like this, and this is the point, let's say, if I draw the tangent, you can see that it is parallel to the x-axis somewhere over here. It means that my dy dx, or the slope of this, is equal to 0. So I've already found out my dy dx. That is why in the question they have mentioned the word hence. So I need to utilize this dy dx and put it equal to 0 and try to form a relationship between x and y. Once I'm having that relationship between x and y, I can substitute it over here and try to find that exact x value for that stationary point. So let me go ahead and show it to you how I can do this. If you have watched my previous video, I have mentioned that if your dy dx equal to 0, you can just say your numerator is equal to 0. Because of course, if you multiply on both the sides with x cos y and the ln x plus 2, on the left hand side it will just be 0, and on the right hand side it will still just get cancelled out. So you are just having x minus sine y is equal to 0. We are going to say that dy dx equal to 0, and this implements that your x is equal to sine y. And now because you are trying to find the x value, you are trying to make substitution of y. And if you look into the question, there is a sine y already given to us in the equation. And we got that sine y is equal to x. So I can directly go ahead and say that wherever there is a sine y, I can write it as x. So let me show it to you how it's going to look like over here. We had sine y ln x is equal to x minus 2 sine y. Now we are going to substitute over here. So it will become x ln x is equal to x minus 2x. So over here, let me just erase this part over here. This is something that I don't want to have. Okay, so now if you can see on both the sides, I am going to have x ln x. Over here, this is minus x, so I'll bring it on the left hand side. It will become plus x is equal to 0. I can take x as the common factor. So I have ln x plus 1 is equal to 0. Therefore, either my x is equal to 0 or ln x plus 1 is equal to 0. That means ln x equal to minus 1. Now what can I do after this? I'll just create a compartment over here and continue my working on the right hand side. So this implements that x equal to 0 first of all will be rejected because ln of 0 cannot be accepted. So I can clearly say that over here x equal to 0 is rejected, as ln of 0 does not exist. DNE means does not exist. So I'm just supposed to solve ln x equal to minus 1, and I can take e as the base on both the sides to remove ln. And finally, I'll have my answer over here as e power of ln x is same as writing x. And on the right hand side, I'm having e to the power of minus 1, which is same as writing 1 over e. So this becomes our final answer for the second part. Clearly, we got two solutions. If you did not reject x equal to 0, of course, you will not get the final mark because x equal to 0 clearly won't work, because if you put x equal to 0 over here, the equation would not work. So yeah, that is how you solve this question.